I don't have a lot of streaming equipment, so you're gonna have to bear with me here. So let's get to it. The goal of this, and that's kind of last minute, just figured I'd put some out there. Might as well. Goal of this is to hopefully finish assembling the Borealis launch pad for Aurora. So let's get the workbench set up here. I'm going to do a lot of preparing for this. We're going to check the live stream quality on my computer. It's okay. It's not great. It's alright. So, let's get to it. Alright, right here we have the final launch tower mechanism. This is really simple, and this is the first iteration of the design for the tower, and I'm not a huge fan of it. It does work, I tested it, but I'm not a huge fan of it, and I'm definitely I'm going to redesign it before I make it available commercially. But it's a pretty simple concept. Basically, there's a servo that gets mounted on the inside here, and then there are clamps, and the clamps obviously are going to clamp the rocket and then open up right before flight. Why I don't like the design, it's really small, it's hard to work with, it's sleek looking, but the problem is, not only is it hard to work with like I just said, but I feel like the clamps need to open just a little bit wider. So in the future I'm going to probably modify that design so these can open wider, because you want them to hold the rocket and then not be in the rocket's way. And what I actually might do is I might change, like I might keep this design the same, and all I would change is the mount down here. I'm thinking of making this motorized at the bottom, so that there's a pretty thick gauge servo. So basically this mount right here would be the same, and then like from here out this would be turned into like a hinge, like a follow-away, and then the servo would drive that away like that before launch. And I think I'm going to go towards that. Just because I think that might work out better. But yeah, so this is kind of the first version of this tower specifically. Some of the other parts on the rocket have already been iterated several times, so they're like a little bit better. But we're going to start with the wiring of this guy. So I'm going to clip the connector down here, which is like my least favorite part because I love these connectors and it's so painful having to cut them like that. Add it to our little collection in there. Close that up. And now I'm going to get the soldering iron turned on and ready to go. And I'm going to go wet my sponge real quick. Alright, so I'm going to get to it here. So I already cut some wire to length, and kind of one of the trickier parts of the design is managing the wires through the tower, and because of how thin it is, I'll show you what I'm talking about here in a second. Because of how thin it is, there's not a lot of room inside the tower to route my wires through, so that makes it really difficult to route those wires. So what I'm going to do, actually, I'm going to feed them in through the top first, because that is going to be a little bit easier, and then I'll pull them out the bottom. Alright, so we're going to take our servo here, and we're going to wire our servo. So you can see I'm splitting the casings. Actually, shout out to Will Smiley for these freaking awesome wire strippers. Boom. That's awesome. So I'm going to strip these guys like that. And I'll do this guy. And this guy a little bit longer. There you go. So the wires are stripped. And I'm going to grab my helping hands real quick. Alright, let's start with the positive. And then I do want to heat shrink these, but it may be challenging to get the heat shrink inside the watchtower. Adjust the camera, and actually we're going to get a defumer going here. Alright, the femur's going. Actually, let's angle this down. Closer. That guy. See if I can get the camera to focus here. Well, just leave it like that then. Okay. Negative wire. Okay, heat gun time. Alright, we're going to let the heat gun warm up for a few minutes. And we're going to get some heat shrink on those wires. So, what I like to do is, I like to cut, let's see, find a piece that's the right size. There we go. I got this whole pack of heat shrink from Amazon, and it has been extremely helpful over these past few years with all the products. So let's start with the positive, since that was what we started with in the first place. And I'll do this guy. Alright, heat gun is pretty much warmed up at this point. Alright, that should be good. So yeah, this guy should be relatively simple to get in there. Once we get it in, it's voltage output positive. Servos will clamp down, same with the ground. Signal, it'll just be in the same bank, so like one more down, and we'll have to program it in to our pad software, but it shouldn't be too difficult, hopefully. But yeah, so there's our servo, MG90, and all I did was extend the leads so that it can go all the way through the tower, and hopefully I'm going to stick all of the leads through the tower here. Twist them up. Alright, there we go. Got them out the other side. So now pull a servo through. And boom, there's our servo. So now the servo's installed, and yet we have wires coming out the bottom of our tower, just as intended, so that it can get wired into the pad. So next, what I think I'm going to do is take a drill and drill out that hole for the LED. And I'm still on the fence of whether we're going to be able to pull off the LED situation, just because we're already super tight on space with this thing, and it's going to be challenging to figure out how to get wires in the tower for those guys. So we'll see. Hopefully I can. If not, that's okay. Actually, make sure I don't just drill through all that hard work right there. Just take it out and I'll feed it back in later. Alright, so there we go. Guys fixed up. And now I can run those wires back through. So I think what I'm going to do next is I'm going to run the wiring back through the tower and bolt the servo down. That way I can do a quick mechanical check to make sure that the tower works okay still. So I'm going to take the servo, we just added our longer leads to, we're going to twist it. And send it through here. Actually gonna take this guy and hopefully aid in getting that down there. Once I get it started, it's relatively easy to get it through. Well, I got it once. I don't know if we can get it again here. Oh, no. There we go. Oh, wait. I don't know. Let's see. Did I get it? Did we get it, folks? It's not going. So I'm gonna try something else here. We're gonna do one lead at a time. Starting with this little guy. Yellow. I don't really know what it's getting stuck on in there. It looks like it's a straight shot. Maybe if there's a support that come all the way through. I don't really know. I'm gonna get it through, ladies and gentlemen. I know it. There we go. Oh, what? So much more difficult that time. Alright, let's do red next. Alright, got the red. Let's get the ground. Hot's in, now let's just get the ground. Should be coming out soon. Yep, there we go. Alright. Let's get this whole thing fed through. Heat shrink now. Yep. Bada bing, bada boom. Alright, so wires through. Now what I'm going to do is take our servo screws and let's see, this guy, I'm trying to think of the best way I can do this. Alright, so what I usually do when I'm putting these claws on to get them on fast is I'll do the non-motorized one first. And I'll show you what I mean. So I'll put it with the servo, or I'll put it on before the servo, before I put the servo fully on, right? So I'll tilt the servo out like this, take this one, this claw, slide it on the support like that. Then I'll slide this servo back like that. Let's see if I can. There. And you can see the gear is going to sit right on that lip of the servo. I have good lighting, but you can see the gear is going to sit right up on that lip of the servo like that, and then I'll put the second claw on. So, but before I do that, let's see. So basically, before I put the second claw on, I take the first claw and I rotate it all the way over like that, so I can get the screw in for the servo. And usually you want to adjust it so that the servo is as far over / closest to the gear as you can get it. So I'm gonna tighten it down now, as is. Alright, I'm going to do the second one. And if I can get it here, that would be great. Alright, so servo's in. See, it's nice and tight. Now we're going to take our second claw, and that claw, we're going to line it up so that it goes on straight and in line with the second one. So now you can see that claws are installed. It's nice and sleek looking. There's not a lot going on. And so when that servo actuates, the gear is going to drive the second claw open. So basically, right 3 seconds before launch, these are going to open like that. Then after the rocket takes off, they will close. And that was kind of the intention with the Borealis claw support. So now, let's look at LEDs and if we can figure out exactly how we want to install LEDs. And I'm going to do a quick function check, make sure that this has got enough wire for each. Okay, so let's figure out LEDs now. I'm going to take out my box of LEDs in here. And quite truthfully, I might start another live stream, just coding them or something. Or, I mean, doing the code for this and the lights and all the other stuff on the pad that I haven't done yet. But we'll see. So LEDs here. I'm going to start with one, but we're going to want three. And you can see, basically, the whole point is I want to be able to stick it. I want to stick one LED on the inside of each hole in the top here. So now that we've got our claw supports installed on the servo, what I want to do is, the idea was to have 3 LEDs, one in each hole here. Now because we're kind of limited on space, like you can see, for this LED to be fully recessed, which actually right now I can't because of the way the legs are, so let me bend them out just a little bit to make an example if I can. I can't, never mind. But what I was trying to say is, you can see the tower like this, the LED to be recessed, there's not a lot of room. So, you know, I'd want it to stick out a little bit, but there's not really a lot / enough room for me to do that. So what I could do is I could leave them so that they're sticking out, and I'll do it on this side so you can better see the example I'm talking about. I can leave them sticking out just a little bit, and it's not going to look as good, but I could do that. If I can get this one seated really quick, hold on. Like that, kind of. So have them a little bit recessed in there, sticking out. That might be okay, and I might do that. Or what I could try, since, you know, this is all we're working with wiring-wise, this amount of space here, which is about 1 inch by, I'd say maybe 1/3 of an inch, a quarter, a little over a quarter. So what I could do is I could see if I could just run one LED up behind here, seat it there, and then hopefully that would like amplify out the 3 holes. I don't want to do that. I'm going to try to do them individually. Now it comes down to how we're going to wire them. Are we going to do series or parallel? So I was thinking series because it'll take up less space, or less wiring than a parallel setup would probably take up. And I can't get this LED out, oh my goodness. But those both have different calculations, or I mean, yeah, calculations for a resistor, but it's really simple. You know, a tiny bit of physics, you know, ohm laws. So basically we can use values to determine what resistance we need for LEDs, whether we're running them in series or parallel. So I'm going to take out 3 LEDs, and I say we just go with it. Some of these other LEDs, I thought the clear ones were RGBs. I think they're just white. Actually, they are cool RGBs. Those would have been cool if I would have thought about it more. When I was catting this, I would have allowed for more space, and I probably would have ran RGBs to do different pad statuses, but I'm just gonna stick with the reds because they look cool. So let's do red. And I actually don't even know, these might not be like true red, these might just be white LEDs in a red case scenario, but we'll see. So let's get another one out here. It will cooperate with me. Alright, there we go. 3 reds for the tower. So now what I'm going to do is stow these other guys away. Like that. Boom. And what we want to do next is a parallel circuit. Now, typically with an LED, you would have a longer contact and a shorter one, and the longer, I think, is the anode, and the shorter is the cathode. I could be flipping those. Anyway, the longer is usually the positive. It's supposed to be. Sometimes manufacturers just do whatever they want and they screw it up. So that's how it's supposed to be. So hopefully that's the way it is. Alright, what I'm going to do is I'm going to resistor or losing internet. Okay, so for those of you interested in how the pad works, let me know, and I will do a quick demo. Let's see. So right now, this is kind of the functionality of the pad. In the back here, there's a computer with a cover, and there are 2 batteries in here, one for the computer and one for the built-in ignition. So basically this pad has, I'll just describe all the features. So in the front here, you can see there's 2 switches. This is for the main power the board, provide power to the board on the. This switch is for the pyro channel. You can see this computer is equipped with several pyro channels. In this case, I'm only using one. But it actually has a built-in ignition system, so I don't even need like a launch controller or any of the sort. The pad is going to light the rocket for me. So you flip that guy, that basically enables the pyro circuit to work, and the LED shows you your continuity on the switch. So what we're going to do real quick here is I'm going to first manually set the clamps. This is a clamp down launch pad, so basically it's going to hold the rocket down. It's going to hold the rocket down a little bit just so that the thrust starts building up. I can kind of change the timing for the clamps, so if I didn't want them to really be holding the rocket down while it's under thrust, I could have them release earlier. If I wanted it to hold it down longer, I could have them stay on longer. I did an individual clamping system. Some people I've actually seen have ran 4 clamps, but from one servo. But the downside to that is you need a lot of complex gearing, and it makes maintenance really hard. And believe it or not, even at this scale, these rockets, they damage components on your pad very fast. They will oxidize all of the metal, and bolts will rust like that. They'll melt through a lot of things. So they do abuse the pad quite a bit. So maintenance with that type of mechanism was going to be harder. So that's why I went with this simple mechanism. And I also wanted it to be available for commercial use. So you can see I just threw the main switch for the computer, and that the LED is now active. Over here you can see the speaker. Inside the speaker there's a piezo, and this will give me audible signals. Right now all of them aren't plugged in, all of them aren't coded, hard coded, but right now it does do an audible countdown. So over here you can see this button interface, canned and printed. I can adjust my countdown as wanted. So in this case we'll do 15, and then I can go over here. Right before I'm ready to launch, I'm going to open the side hatch on the rocket, enable the thrust vectoring and all the onboard avionics. Then we'll throw the main switch, or not the main switch, the pyro switch. So now the rocket is ready. I can start the countdown. So now it looks like I have a clamp that is not functioning. I don't know what that's about. Should not be doing that. There we go. And just to ensure proper functionality, what I'm going to do is test it one more time. So this clamp down mechanism actually works fairly well. What I'm going to do probably is replace the servo horns for the clamps and make them a little bit thinner at the tip. That way there's less surface area holding that clamp so they deploy faster, and there's less chance of horn getting stuck, which has happened a few times, but hopefully not enough to be a problem. Yep, so looks like everything functions right currently, so now what I'm going to do is remove power from the computer. And there you go. So, that's how the pad works. And now we can get back over here. We're going to figure this situation out later. I'll figure out that LED situation out later. It shouldn't be too hard, but yeah, for right now, I think I'm just going to end the stream and I'll figure out the LEDs later. So, thanks a lot if you joined. Thanks for checking it out, and I will get LEDs in there. And I think I'm going to do a separate live stream at some point as I'm adding in the code for those final components. Just something simple, but kind of bored, so I'm going to do it. So, thanks again. See ya.